So this is 11th lecture of Unit 5. Here we will discuss about global data flow analysis, some of the part. Global data flow analysis. All the optimization depends on data flow analysis, and data flow analysis refers to the body of techniques that derive information about the flow of data along the program execution path. For example, one way to implement global common subexpression elimination requires us to determine whether two textually identical expressions evaluate the same value along any possible execution path of program. The execution of a program can be viewed as a series of transformation of the program state which consists of values of all the variables in the program. Each execution of an intermediate code statement transforms an input state to a new output state. The input state is associated with the program point before the statement, and output state is associated with program point after the statement. When we analyze behavior of a program, we must consider all the possible sequence of program points through the flow graph that the program execution can take. In more complex analysis, we must consider paths that jump among the flow graphs for the various procedures such as call, return, etc. For simplicity, we can concentrate on the path through a single flow of graph for a single procedure. Let us see what the flow graph tells us about the possible execution path. Within one basic block, the program point after a statement is the same as the program point before the next statement. If there is an edge from block B1 to block B2, then program point after the last statement of B1 may be followed immediately by the program point before the first statement of B2. Thus, we may define execution path from point P1 to Pn to be such that for each I equal to 1, 2, n minus 1, either Pi is the point immediately preceding a statement and Pi plus 1 is the point immediately following that same statement, or Pi is the end of some block and Pi plus 1 is the beginning of the successor block. In general, there is an infinite number of possible execution paths through a program, and there is no finite upper bound on the length of an execution. The program analysis summarizes all the possible program states that can occur at a point the program will with a finite set of facts. Different analysis may choose to abstract out different information. In general, we can say that no analysis is necessarily a perfect representation of the state. So let us see this example. Consider the following simple program which is represented here in 9.12, which describes the unbounded number of execution. Here you can see that here is a point 1, point 2 in block B1. Block B2 we have 3 and 4, and block B3 we have 5, 6, 7, 8, and B4 we have 9. So you can see here that not entering a loop at all, अगर किसी भी लूप में एक बार भी ना जाए तो शॉर्टेस्ट कंप्लीटेड पाथ क्या होगा, पॉइंट 1, पॉइंट 2, then point 3, then point 4, और चूंकि ये लूप में नहीं जा रहा था, here the condition will be false. From here we will jump direct to the B4. So we have here 1, 2, 4 and 9. और अगला शॉर्टेस्ट पाथ क्या होगा, एक बार लूप चले बस. तो फॉर एक बार लूप चले, फॉर दिस केस व्हाट वी हैव, पॉइंट 1, पॉइंट 2, पॉइंट 3, पॉइंट 4, देन 5, 6, 7, 8, and after it again we have 3 and 4, and then we have B4, that is 9. So this is the next shortest path. So in first time the program at point 5, इस point 5 की अगर हम लोग बात करें, ये point पर अगर हम लोग consider करते हैं, the value of a is 1 क्योंकि d1 equal to a equal to 1 होगा. So what we can say that a1 is 1 due to definition d1. वी से दैट D1 रीचेज एट 0.5, इस 0.5 पर ये रीच कर रहा है इन द फर्स्ट आइट्रेशन। इन सब्सिक्वेंट आइट्रेशन, अगले बार जब आइट्रेशन जब वो चलेगा, देन D3 रीचेज एट 0.5, तो ए की वैल्यू यहाँ पर अब 243 हो जाएगी इस पॉइंट पर। सो इट इज़ नॉट पॉसिबल टू कीप ट्रैक of all the program states for all possible paths. In data flow analysis, we do not distinguish among the paths taken to reach a program point. We do keep the track of entire state. Rather, abstract out certain detail, keeping only data we need for the purpose of the analysis. So we will see here two example. First example, in first example you can see here, find out to help users debug their program, we may wish to find out what are all the values of a variable may have at a program and where these values may be defined. तो a की वैल्यू क्या होगी वो हम लोग इसको चाहे तो ट्रैक आउट कर सकते हैं. फॉर इंस्टेंस वी कैन समराइज लाइक दैट एट द 0.5, इस 0.5 की अगर हम लोग बात करें तो ए की जो वैल्यू हो रही है वो क्या हो रही है, 1 हो रही है और 243 हो रही है. एंड दिस इज डिफाइंड बाय D1 एंड D3. डेफिनेशन D1 और डेफिनेशन D3 में ये डिफाइन किया गया है. नेक्स्ट, द डेफिनेशन दैट may reach a program point along some path known as the reaching definition. तो ये reaching definition के थ्रू ये यहाँ पर reach out यहाँ पर रहा है. तो एक ये चीज़ आपकी हो सकती है कि ए की वैल्यू हम लोग यहाँ पर देखना चाहते हैं. नेक्स्ट एग्जाम्पल ऐसा हो सकता है कि सपोज इंस्टीड वी आर इंटरेस्टेड इन इम्प्लीमेंटिंग द कांस्टेंट फोल्डिंग. यहाँ पर हम लोग चाहते हैं कि कांस्टेंट फोल्डिंग करना चाहते हैं. सो इफ़ वी यूज ए वेरिएबल x is reached by only one definition and that definition assigns a constant to x. तो x को एक constant हम लोग define करते हैं, then we can simply replace x by a constant. x की जगह हम लोग constant डाल सकते हैं. But several definition of x may reach a single program point no matter which execution path is taken. किसी भी execution path को अगर हम देखते हैं तो x की वैल्यू क्या है ये हमको चेक करना पड़ सकता है. So for the point number 5 in this figure, there is no definition that must be the definition of a at that point. So the set is empty for a at point number 5. यहाँ पर a की वैल्यू क्या होगी, क्योंकि कोई भी यहाँ पर कांस्टेंट नहीं है यहाँ पर. Even if a variables has a unique definition at a point, the definition must assign the constant to the variable. Thus we may simply describe certain variables as a not a constant. मतलब किसी वेरिएबल को आप नॉट ए कांस्टेंट बोल सकते हैं या फिर वेरिएबल बोल सकते हैं. तो इस तरीके का भी इंफॉर्मेशन हम लोग चाहें तो कलेक्ट कर सकते हैं फॉर द ग्लोबल डेटा एनालिसिस. So thus we see that the same information may be summarized differently डिपेंडिंग ऑन द पर्पस ऑफ द एनालिसिस. किस तरीके का एनालिसिस करना चाहते हैं आप, चेक करना चाहते हैं कि वो वेरिएबल है या कांस्टेंट है, ये चेक कर सकते हैं, या फिर ए की वैल्यू क्या है वो आप चेक कर सकते हैं. तो इस तरीके से हम लोग चाहें तो यहाँ पर डिफाइन कर सकते हैं.